Alright, so you may have done this in pre-calculus. I don't know if they do something like this in Algebra 2. I don't think so. But even if you haven't, I'm going to show you how to do it now. So partial fractions are basically like if we put something together with a common denominator, we're going to take it apart. So we're going to spread it out into two things. You can kind of see they have an example right here. So I'm just going to get started. So what we would want to do is factor. The ones that I've seen on the AP exam are usually not that bad. I have a worksheet of them, I think, in your notebook right after this. So those are the ones from the AP test, and they're usually not that big of a deal. So this is positive, and that's prime, so they've got to have the same sign, and it's negative in the middle. So those are both going to be negative. All right. So what we want to do is we're going to say 1 over, I'm going to switch those around, x minus 2 and then x minus 1, like that. And so that should be equal to something over x minus 2 plus something over x minus 1. Okay, so that's probably not that big of a deal, especially if you remember it from pre-calc. So then we're going to multiply the whole thing by the denominator here. So that's going to give us a 1 there. And then here we're going to have a times x minus 1 plus, and here we're going to have b times x minus 2. Because here the x minus 1, x minus 2 both cancel. We just have 1. Here the x minus 2's cancel. We just have x minus 1. Here the x minus 1's cancel, so we just have x minus 2. Now, let's think about this for a moment. What if we let x equal 2? Okay, if we let x equal 2, then this would be 0, this would be gone. If we let x equal 2 here, that would be 1, and then we would just have that 1 equals a. Right? Now, or we could say, what if x equals 1? If x equals 1, this would be 0, this would be gone. If x equals 1 here, that would be 1 equals negative b, or b equals negative 1. Okay? So we can come back here to our integral, and we could say, let's take, instead of the integral of that, let's take the integral of a was 1, so that's going to be 1 over x minus 2, and b was negative 1, but I'm going to write it right here like that. Okay, and now we can take the integral of those. Hopefully we can, because that's the natural log. 1 over x, or 1 over u, is the natural log. So that's going to give us the natural log of x minus 2 minus the natural log of x minus 1 plus c, or when you subtract logs you can divide, so that would be the natural log of x minus 2 over x minus 1, which I suppose maybe looks a little cleaner, but if it's multiple choice and you don't see that anywhere, then you would try to, oh, I can rewrite that. Try that out. Alright, so hopefully you could pause and try the next one yourself. Although it's a definite integral, so there's a little bit of a difference, but at least the beginning part of it ought to be the same. So I'm going to continue because you're supposed to be paused. So x times x plus 1. So that's going to be 1 over x times x plus 1 equals a over x. Now you can switch those around. It shouldn't make a difference. If you switch those around, that means you would just be switching, like in our last problem we have 1 and negative 1, you just would have got negative 1 and 1. So it still should come out the same. So if we multiply the whole thing times x plus 1, that's going to cancel. We'll just have 1 here. Here we'll have a times x minus 1, and here we'll just have b times x. So if we want to find a first, we could let x equal 0. So if we let x equal 0, that's going to be 1 equals negative a, or a equals negative 1. I made a mistake here. That should be plus. Why didn't you guys tell me? So that should be plus. So if that's 0, then a just equals 1. So, oops. Okay. So foreshadowing there if you're wondering what's going on there. So if we let x equal negative 1, then this would be 0, and that would be negative b. And then we can divide both sides by negative. So b equals negative 1. Okay. So now we're going to integrate from 1 to 2. A was 1, so we're going to have 1 over x minus 1 over x plus 1. So that's going to be the natural log of x minus the natural log of x plus 1 from 1 to 2. So we could, just like the last one, we could combine those. So we could put x over x plus 1. So if we plug a 2 in there, we're going to get the natural log of 2/3 minus the natural log of 1/2, and we can divide, so the natural log, so I have 2/3 over 1/2. So that's a complex fraction. We could just multiply by 6 over 6, or you could multiply by the reciprocal. So that's going to be 4 over 3. All right. And we have 2 more of those. Now, as we look at this next one, what should stand out is that we have x cubed over x squared. What should also stand out is it says long division above it, so pretty much telling you what you need to do there. So you might be able to use synthetic division sometimes, but I don't remember with this x squared there. So I'm just going to do long division. Now be careful when you're writing this out. If you're missing a term, you got to put a 0 in there, a placeholder. But we were not missing any terms there. So if it just would have been x cubed plus 5x, I would have put 0x squared there. And then we have x squared minus 1 here. So just like if it was numbers, you're trying to multiply and eliminate these as you go across. I'm going to multiply by x. So that's going to be x cubed and then minus x over here. And then you subtract just like you do with numbers. So these are going to cancel. It's kind of the whole point. This is going to come straight down like it is. This is a little bit tricky here. So you're subtracting that. That was a negative, so that's a negative, negative. That's a positive, so that's going to be plus 6x. And then that comes straight down. You're not subtracting that. Okay. Then we want to get rid of this now. So we're going to multiply by negative 6. So that's going to be negative 6x squared, and then plus 6. So this 6x is going to come down here. That's going to be minus 6, so that's going to be minus 9. All right. So if we look at what we have here, if we start off, so there's going to be a remainder there, so that's going to be plus 6x minus 9 over x squared minus 1. So before I start to do that, I'm going to do the partial fraction decomposition of this. This looks a little more interesting than the last couple we had. It doesn't just have a 1 in the numerator, so maybe that'll be more interesting. So we have 6x minus 9 over x plus 1, x minus 1. And so that's going to be a over x plus 1 and b over x minus 1. Alright, so we're going to multiply the whole thing by the common denominator, and so that's going to be 6x minus 9. And this is going to be a times the x plus 1s will cancel, so it'll just be x minus 1. And here the x minus 1s will cancel, so it's just going to be x plus 1. Okay, so let's get rid of b first. So if we let x equal negative 1, that'll be gone. If we let x equal negative 1 here, well, let's go over here first. So that'll be negative 15. And if we let x equal negative 1 here, that's going to be negative 2a. So if we divide both sides by negative 2, we're going to get 15 over 2. Alright, that's a little awkward, but okay. Now if we let x equal positive 1, that's going to be negative 3. And positive 1 here will be 0, that'll be gone, and this will be 2b. So b is going to be negative 3/2, like so. So that's a little bit awkward, but let's see what happens. So we have the integral I'm going to spread the whole thing out. So we have x minus 6 dx. Then a was 15 over 2, so we're going to have plus 15 over 2. I'm just going to factor that out. So that's going to be 1 over x plus 1. And then the last one, negative 3/2, factor that out, and that's going to be 1 over x minus 1. So we have those integrals to look at there. So add 1 to the exponent, divide by the new exponent, minus 6x there. And then we have 15 over 2, natural log x plus 1. And then we have negative 3/2, natural log x minus 1, and then plus c. Did I forget the plus c on that other page? Oh, that was it. No, we're fine. All good. Alright, so we can try to clean that up a little bit. What do we want to do there? So we've got 1/2 x squared minus 6x. Now, what if we factor out a negative 3/2 here? So if we put a negative 3/2, and then, so this would be or just a positive 3/2. If we do a positive 3/2, that's going to be 5 natural log x plus 1 minus natural log of x minus 1. And we still have the plus c over there. So now we can take that in as an exponent and write this a division problem. So we could put 3/2 using properties of logarithms. I guess we could go x plus 1 to the 5th over x minus 1 plus c. So Alright. Alright. I don't remember seeing one like this on the AP exam, but if we're going to do this, we might as well do the whole thing, I think. Although I didn't do the secant squared or powers of secant, so I guess that's not always true. But, alright. So, here, this is not long division because the numerator's power is not larger. So we're going to try to factor this. It shouldn't be that bad. X and X. 2 and 2, same sign, so both negative because that's negative. So we're getting x minus 2 squared. So that's called a repeated linear factor. So we have it twice. So we start off with 7x minus 11 over x minus 2 squared. And then we start off with one factor. So we're going to put a over x minus 2. And then we put the squared version of that. And if it was cubed, then we would have to have another one with a cubed, x minus 2 cubed. So that's the main step when you have a repeated linear factor. Use whatever that is to the power, you have to do it every single power of that. So if it was the fifth power, you'd have to have that, and then to the third, and then the fourth, and then the fifth. Okay. But now, mostly it's the same. You got to do a little bit more work on the system of equations here. So if you multiply this whole thing, you're going to get, by the common denominator, you're going to get 7x minus 11. And then here, you're going to have a times x minus 2. But then on the end, you're just going to have b because that's going to cancel out. Okay? So we still can we can let x equal 2. So if x equals 2, this will be gone. That'll be 14 minus 11, so that'll be 3. So then we find out that b equals 3. And so if b equals 3, we can do what? Well, actually, we can find this out faster. So we could, if we multiply this out and we have ax minus 2a plus b, well, you notice that the only term with an x in it is this term. Okay, so like I said, we could try to plug that in, do something, but I can see that a has to be 7. Like there's no other choice. So, a is 7, so I can factor that out, 7. And then I'm going to have 1 over x minus 2. And then b was 3. So I'm going to put 3. And then 1 over x minus 2 squared. Now, I could use a u substitution, but because that's because the chain rule in there is just 1, the derivative inside there is just 1, I could probably think about this as to the negative 2 power. Okay, so if I go over here, 7, that's the natural log of x minus 2. That's fine. Okay, here, got that 3 there, let's hold on that. So if I add 1 to the exponent, that would be x to the negative 2, and then divide by the new exponent, I would have that. So that is going to be negative, and then I've got the 3 there, and that's not a natural log. And then don't forget the plus c, which I hadn't integrated yet there. So that's it. So because u, if I would have used a u substitution and du would have just been dx, I was okay there. Nothing weird was happening. So I could just do a rewrite on that and integrate it from there, probably. All right, that's it on day 1 of partial fraction decomposition. It's about that time.